the final topic that I wanted to cover today was high-performance computing. And so high-performance computing can mean a handful of different things to a handful of different people. Basically, I want to talk about this as high-performance computing using NVMe over Fabric. And I want to keep this, again, entirely focused on workload, not focused on technology and underlying protocols and all this crap. So the workloads would be like banking. So banking wants this form of high-performance computing because it's very low latency. So lots of banking transactions count on the ability to work very quickly. This is, of course, like making sure your bank account doesn't get doubly accessed. How many people read the book Flash Boys? Okay, so you know what I'm talking about, where they're like the banking companies that went out and dug a fiber across Pennsylvania and Ohio so they could have a single link between New York and Chicago. So to be very low latency. Anyway, banking needs the really low latency stuff. Things like fluid dynamics. This is like fluid dynamics, believe it or not, actually applies to aerodynamics as well. Because the air gets treated as a fluid in that case. But the whole idea is that there's lots and lots of data that you need to process very quickly, and you need to typically do it in very parallel streams and be able to crunch it as a matrix, not as a single stream. So fluid dynamics is a big reason why you want very wide path with lots of queues and the ability to do it. And the final is things like medical and nuclear research, where you are getting loads of data that you need to be able to transfer around, and you don't want to spend all day transferring basically 5 gigabytes or 100 gigabytes of data from one place to another. So you want actually a very thick path to do this. So these are potential places where you would use you would need very low latency, very high bandwidth, very multiplexed paths. So here's where my cynicism comes in. I largely think of the NVMe over Fabric effort as a way of grafting Flash back onto a skeleton of Fibre Channel. Fibre Channel is well and truly dead at this point. It's just kicking because people keep thinking that it's important, and I largely say this because Fibre Channel is mostly out there for high margin vendors. So people who have the idea that there's actually I can make 60% margin on a piece of hardware rather than buying something commodity. They come up with some new use of Fibre Channel thinking that, hey, all of a sudden I have a new way to make a high margin type of equipment. Again, very cynical, I understand this, but it's my take on it for a long time has been the more stuff that you can run as commodity hardware, the better off you are, no matter what. And anything that tries to come up with a new use for Fibre Channel is certainly not talking commodity hardware and certainly not talking a commodity use of that hardware. And the final one is it's like, we need a road from InfiniBand, because I've often referred to as NVMe over Fabric as the next InfiniBand. It's again not a commodity. There are uses for it. It's a niche protocol that gets used for places that need that very specific protocol. That being said, in all my cynicism, VMware seems to think it's the future. So if anybody listened to Duncan and Brian Young yesterday in their session, they talked about VMware working on a virtual NVMe. So currently everything that you run in a VM is presented up through virtual SCSI, and they're moving to what they're calling virtual NVMe. So your VMs will have a virtual NVMe adapter in them. And they're talking about iSCSI, Fibre Channel, and NFS becoming NVMe over Fabric. So, VMware is at least looking down these lines as well. I have no better ability to predict the future than anybody else. I gave you my cynical view, and now I'll give you the views of others as well. We've gone from the idea of everybody sitting obediently in their rows in their data center, doing the exact same thing and learning the exact same thing, to VMs and data center loads being able to take advantage of various different aspects of the data center and doing what they need to express their own personality and be themselves. And that's all I had, folks.
So you described a lot of this hardware resources shared across.
Oh, I'm sorry. No, since this is a NetApp session, I did want to mention how these technologies tie into things that we're doing. So we have the memory enhanced FlexPod, which takes advantage of persistent memory, and it uses a cache system within the UCS blades in FlexPod to basically accelerate the capabilities of the underlying storage. So this is where persistent memory is coming in, and that actually applies to all of the workloads in that system, not just the specific database in-memory databases that I talked about. We have 2 compute nodes. How many people knew that NetApp sold compute? Seriously? That's it? So, by the way, NetApp sells compute.
That's a lot of us.
Half.
You need to talk to marketing.
Yes, I realize that. So NetApp actually sells compute, and we actually sell 2 compute nodes that have GPUs in them. So we have one that has a pair of M10s in them, and that's graphics only. And just yesterday, we announced ones that actually have 3 Tesla T4 processors in them, which are both Tensor and CUDA cores. So they're intended as dual purpose. And we certainly have our FAS has a NVMe over Fabric interface on it, and we're working very closely with VMware on the integration of that to make sure that we're one of the first vendors out there who actually takes advantage of the VMware integration.
We have that with Brocade as well. We have it in verified architecture. So if anyone's interested, see us offline.
Anyway, that's what I had to talk about. I hope that you found it useful, interesting, entertaining.
Back to my question at this point. You talked about sharing a lot of hardware resources for this.
Yes.
Workload. What do you think about IT composability? I mean, doing it at the hardware level and not at the hypervisor level. Okay. Because I saw also during this VMware a couple of sessions where they are starting to somehow talking. VMware started talking about the composability of the hardware to make
Right.
ESX resources more. ASX can borrow resources from other computers, other pool of resources, not just the local resources.
I mean, they certainly do a little bit of that with their GPUs, and I'm going to be perfectly honest, I have not looked into much of this at all. So it's something. It gives me something else to look at, but
Sorry about that.
I don't have a good answer. Here, read my shirt.
There's actually the challenge on that is scalability across GPUs using TensorFlow and the other ones is a challenge as it is. Usually you have to just cram a bigger one in there. It's possible, it's harder, especially when you start to try to make it work. And the same rules apply to TPUs. That's why you end up with the Google TPU V3 that 420 petaflops. You got to cram that into one massive thing as opposed to things doing in the teraflop ranges.
No, yes, but on the shop floor there was at least one vendor that is thinking about sharing components through the standard network, Ethernet.
Anything you can sell.
And so I was curious about this because sharing GPUs across Ethernet seems a little bit off to me, but I don't know. It was just.
Well, I mean, certainly some of the GPUs that are out there were intended to be shareable. So the M10s were actually designed with VDI workloads in mind, and I believe they're set up to each handle 60 independent VDI loads with the idea that they would be shared. And I mean, the T4s have multiple functions on them, so I don't think that they're necessarily thinking that everybody will use both of those functions at once. And again, they have what they call a shared direct mode. So there was the concept built into the GPU that it would be shared. I don't know about other things. I've heard about NICs where you can actually have separate functions that get carved off. I haven't ever played with them or done anything with them. I'm sure there's other hardware that's out there as well. I don't know enough to do anything other than shrug.
Well, and the shared functionality of the GPU over Ethernet is what Andy led with. Is they're running the lab out of a machine that's sitting in his garage. So that part, that's already table stakes. That part's easy.
No, yes.
It's the other stuff, like it's
Yeah.
deeper, harder, weirder.